Hi students, in this lecture I am going to discuss problems based on equilibrium of rigid body. Let us see first one. A uniform ladder of length 10 meter and mass 16 kg is resting against a vertical wall making an angle of 37 degree with it. The vertical wall is frictionless but the ground is rough. An electrician weighing 60 kg climbs up the ladder. If he stays on the ladder at a point 8 meter from the lower end, what will be the normal force and force of friction on the ladder by the ground? What should be the minimum coefficient of friction for the electrician to work safely? So this question is taken from H.C. Verma. Let us see the data given and how to start the problem. First, let us make a diagram for the given data. Right, first of all, see what is the data given. It is a uniform ladder length 10 resting against a vertical wall making angle 37 with it. Let us make a diagram. Right. So it is making an angle 37 with it means with wall. This is making 37. Right. So now we have to calculate what will be the normal force and force of friction by on the ladder by the ground. Let us take normal reaction at this point. So taking free body diagram. So from ground, normal reaction from ground, frictional force left side, which is static because ladder is not slipping. Next, wall given smooth, so only normal reaction. Take it as NW from wall. Suppose this is y-axis vertically up and this is x-axis horizontal. And we can take weight of the ladder that is given 16 kg. It is now passing through center of the ladder 16 g and a person somewhere here at a distance 8 meter from the bottom and his weight mg acting vertically downwards, that is now 60 into g. Now write conditions. Net force equal to 0. Since ladder is in equilibrium, net force 0, net torque also 0. Right? So I'm writing first condition along x-axis net force 0. See from this what I can write along x-axis. Horizontally, normal reaction by wall and friction by ground. So first condition NW, normal reaction by wall, is balanced by static friction from ground. So equation 1. Next, take along vertical means along y-axis net force 0. See what we can write. 60G plus 16G, right? 76G. That is equal to normal reaction from ground. Normal reaction from ground. That is now how much? 76 into G. And we can take G value 9.8. Okay. Next. See, next what we have to calculate. So we got normal reaction. Now force of friction. Coming to force of friction. See now what we can do. We can take net torque equal to 0. And as I have discussed earlier, since net force 0, net torque will be same about any point. So we can take about any point, but we have to choose a point so that through that point, more number of forces are passing. Let us call this as point A. This is point B. Now we can take about point A. The reason is that in that case, because of normal reaction from ground and by frictional force, torque will be 0. So net torque equal to 0. That implies you can see about point A because of these two weights, torque will be anti-clockwise. And about point A, because of normal reaction from wall, it will be clockwise. Okay. Normal reaction from wall into perpendicular distance. See how much it is. Ladder length is, see how much given. It is given 10 meter. This is a 10. Distance is now OB, right? 10 cos 37. 10 cos 37. That is equal to 16G. 16G. This is now midpoint, so L by 2. This is a 5. Now this also 37. So we want now this distance, right? 16G into 16G into L by 2. L by 2 is a 5. L by 2 is a 5. 5 sine 37. Sine 37 plus torque due to weight of the person. 60G. We are given now this distance equal to 8 and angle 37. So this becomes now 8 sine 37. 8 sine 37. Right. Now see calculation part. What we can do here. First of all, 16G into 5. 16 to 5, it is 80. 60 into 8, 480. It is now 560. So 560G. NW into 10 cos 37, 4 by 5. That is equal to 560G. Remaining what else left? Sine 37. And here also sine 37, right? That is 3 by 5. 5 gets cancelled. 1 0 gets cancelled. 4 in 56. It is 14 times, right? 14 times. That implies normal reaction from wall is equal to, see how much we get? 14 G into 3. 14 into 3. How much it is? 42. 42 into G. G value take 9.8. And that is approximately equal to 412 Newton, right? It is approximately. Next. So next we have to calculate. What should be the minimum coefficient of friction for the electrician to work safely. See condition for this. If it is about to slip, when you are taking limiting case, it is about to slip. When this is about to slip, this friction becomes now limiting value. Nw equal to Fs. It becomes now limiting value. Therefore, 412 is limiting value, which is equal to mu s into normal reaction from ground. And that is see how much? 76 into G, right? And we are taking now G value 9.8. So 76 into 9.8, approximately 745. Okay, normal reaction from ground. So 412 is now limiting friction. Then from this we get the value of mu s. That is, see how much we're going to get, approximately equal to 0.55. Okay, that means simply focusing on net force equal to 0, net torque equal to 0. Okay, let us take next problem. And this question also taken from H.C. Verma. See the question given. The door of an Almirah is 6 feet high, 1.5 feet wide, and weighs 8 kg. The door is supported by two hinges situated at a distance of 1 feet from the ends. If the magnitudes of the forces exerted by the hinges on the door are equal, find this magnitude. Okay, right. Let us make a diagram for the given data. So it is given that an Almirah given dimensions, so 1.5 feet wide and given 6 feet height, and having hinges at a distance of 1 feet, okay, from each end. This is 1 feet and this also 1 feet. Okay, so remaining separation how much? It is 4 feet, and weight is given, mass is given 8 kg. Right, let us see now what we have to calculate. Hinge reaction, right? Condition given that magnitude of hinge reactions is the same. So first thing, the door is now in equilibrium. Therefore, net force equal to 0, net torque also equal to 0. Net force, you can see weight mg vertically downwards, which is equal to 8 into g. Next, coming to here, the door has a tendency to rotate clockwise. Assume that no support from the bottom, means from ground, tries to rotate clockwise. That means here, by the hinge force must be one component, you can say horizontal is H and vertical is V. So hinge reaction is now like this. It is in this way because door is now pushing the hinge outwards like this. You can see here rotation will be, it is a clockwise, trying to rotate clockwise. So hinge reaction must be like this. One component upwards and one is left side. Next, coming to the second hinge, here we can guess direction must be horizontal, must be right side because this must be balanced by some other force and weight is along vertical. So only possibility is now hinge reaction component has to balance this one. So this must be right side and horizontal. Next, coming to vertical, it must be equal to V. So why it is V means, because condition given that both magnitudes are equal. Magnitudes square root of h square plus V square. Okay. So first thing, this must be h because this has to balance this horizontal component. Then obviously these two must be same. Suppose if you take this is downwards, then these two will get cancelled. Then mg will be remains unbalanced. So only possibility this also must be upwards. Okay. V and V, 2V upwards. Mg downwards. So 2V equal to mg. Mg means 80. Means V value, it is 40 Newton. Next, to find horizontal component, now take torque equation. Since net force 0, we can take torque about any point. Let us take about the bottom hinge, about this hinge, because of this H and because of this V and because of this V also, torque becomes 0 about bottom hinge. Remaining is only due to weight mg and due to this horizontal component of hinge reaction. Okay, about this point, because of mg, torque will be clockwise. So mg 8g perpendicular distance. This is given 1.5, half of that 3 by 4. This should balance h into total value 6. This is 1 and this is 1. Remaining gap is a 4. So it is a 4. Okay. So 8 into g. G value 10. So 80. So 4 20 times. And this 4 5 times, right? That means h equal to 15 Newton. Okay. So now we can substitute here. Square root of 15 square plus 40 square. And this is approximately equal to 43 Newton. Okay. So again, net force 0, net torque 0. So here main confusion comes like how we are taking direction of hinge reaction. This is now like this because door has a tendency of rotation clockwise. So this door pulling the hinge outwards. That's why hinge reaction is inwards like this. Once we get this one, remaining we can guess easily because this must be balanced by one component of hinge reaction. So it must be same value, direction opposite. And V must be upwards because if V is downwards, both will be cancelled. And that is not possible. Right? See next one. A uniform wooden stick of mass 1.6 kg and length L rest in an inclined manner on a smooth vertical wall of height h, and this h is less than L, such that a small portion of the stick extends beyond the wall. The reaction force of the wall on the stick is perpendicular to the stick. The stick makes an angle of 30 degrees with the wall. Stick makes an angle of 30 with the wall, and the bottom of the stick is on a rough floor. The reaction of the wall on the stick is equal in magnitude to the reaction of the floor on the stick. The ratio h by n and the frictional force F at the bottom of the stick are. Students, you should be very careful here. That is reaction of the floor on the stick. This wording is not a correct one because reaction means reaction of the floor. Its meaning is force by the floor, reaction of the floor on the stick. See meaning of that, force by the floor on the stick. Okay, that means by the floor frictional force is there and normal reaction both. But in this problem, he has taken only normal reaction. If you are taking in that way, then option will be D. Otherwise, there is no answer. So I think as per the sentence, there is no answer because reaction of the floor. So what it means, it is force by the floor on the stick. So which force? It is friction as well as normal reaction. So as per sentence, no answer. But if you are taking reaction of the floor means normal reaction, in that case, it is option D. Let us now see calculation part. So it is given length of the ladder is greater than height of the wall. Like this. This is now H. Okay. And given that this is now 30. Now focus free body diagram. Focus free body diagram. So as I mentioned earlier, they have taken normal reactions are equal. Normal reaction from ground, it is N. Frictional force, it must be like this. Take it as F. You can see normal reaction here. It should be normal to the contact. It must be like this. Normal reaction. Let us take horizontal as x-axis, vertically up as y-axis. So now I am taking components for normal reaction along vertical and along horizontal. Since ladder is in equilibrium, net force 0, net torque also 0. This is now 30. Now, this also 30 because this is normal to vertical, this is normal to ladder. Okay, this also 30. This is n cos 30 and this is now n sin 30 and ladder weight is downwards vertically 16, right? 16. So its mass is given 1.6. I have taken G value 10, right? G value 10 only 16. So writing net force along x-axis 0. Along x-axis means horizontal. Horizontal means what we can write. It is F equal to F static friction, okay? Because not slipping, static. It is equal to N cos 30. N cos 30. Check it once. Along horizontal friction here. Here component of normal reaction. Next. Taking along y-axis means along vertical. N plus n sin 30. N plus n by 2. 3n by 2. That is equal to 16. That implies n equal to 316. Sorry, 216. 32. 32 upon 3. Right? Newton. That means from this what I can say here. N value 32 by 3 cos 30 root 3 by 2. 2 here 16 times. It is now 16 root 3 upon 3. Okay. Right. Now what we have to calculate here? Frictional force. So we got frictional force 16 root 3 by 3 frictional force. Next, we have to find out ratio, right? H by L, how much? So now take torque equation. Already we have taken net force along X along Y. The only equation left, that is torque equation. So I'm taking torque equation about point A, right? Then see what I can say. Torque due to normal reaction here, that will be about point A. Because of that force, torque is anti-clockwise. And about point A, because of mg, torque is clockwise. So n into, suppose this is point B. What is now AB length? AB length equal to h by sine 30, right? Am I correct? H by sine 30. H by sine 30. That means 2h. That is equal to mg. Mg is now 16. 16. This is now 30. This is now 60. Right? This separation, suppose this is C. AC value L by 2. AC value L by 2, and we want now this length. Okay. This length is L by 2 cos 60. L by 2 cos 60. Okay. Right. In the place of n, I am writing 16 root 3 upon 3 into h. Sin 30. Sin 30 is now. See what is that value? Sin 30 is 1 by 2, right? Wait. Let me cross check once. I have the what? Is it h by sin 30? No. 60 opposite hypotenuse. Sorry. It is now sin 60. It is sin 60. We can see diagram once. Sin 60 equal to h by hypotenuse. Okay. Sin 60. So n value 16 root 3 upon 3 into h sin 60. Root 3 by 2. Okay. 1 root 3 gets cancelled. That is equal to, it is now 16 L by 2 cos 60 1 by 2. Okay. 1 by 2. 2, 2, so 4. 4 here 4 times. And 2 here 2 times. Right. Then see what is the answer. H by L is equal to, here 2 here 8 times, right? H by L. Is anything wrong in this one? Let me cross check once. N value 16. 16. Wait. N value, sorry. N value is 32 by 3, right? Not, this is friction, right? Okay, let me correct this one. N value I have taken wrong. Let us write this one once again. Right. N value 32 by 3. Okay, this is friction. N 32 by 3. 32 by 3 into h sin 60 root 3 by 2, that is equal to 16 L by 2 cos 60 1 by 2. 1 by 2, 2, 2, 4. 4 times here and 2 here. Again 2 times and 2 here. 16 times. So h by L, that is equal to what else left here? 3 root 3. 3 root 3 upon 16. Okay, that is our answer, right? So here we have taken assumption that reaction from the ground as normal reaction. But I think that is not a correct one, because reaction by ground means force by ground, which is resultant of normal reaction and friction. So in that case, there is no answer, right? So I hope you got a clarity. So in this, correct option is means according to that. Okay, if you take that is the normal reaction, then option is D. Okay.